My name is Shazan Fikri bin Muhammad Lutfi. Today, my teammates and I will present to you about our project that is head dryer microprocessor. So we go to the abstract. Since the spread of COVID-19 as well as the latest fashion development, the demand for hair dryer is getting more and more attention. This is due to people taking measure by limiting their visit to the salon. They had to build a mini salons at their home in order to keep up with the latest fashion and trends. As a result, one of the must-have items is hair dryer. So, the project's goal is to use an EZ60SK to implement all of the microprocessor components required to make a hair dryer. Now we move to introduction part. It is now quite simple to purchase a hair dryer with a more than century long development history. One of the first patents describing the hair dryer functioning concept was issued in 1865. A hair dryer accelerates the evaporation of water from the hair surface. Hair dryer emits hot air, which promotes evaporation due to the following phenomenon. Hot air absorbs moisture much more readily than cool air, causing the molecule in the water droplet to evaporate more quickly. A hair dryer has two primary components. The first is heating element, which is a wire with some resistance that converts electrical energy into heat, while the second is a motor-driven heating element. The hair dryer mechanism of operation is straightforward. When electricity is provided to the hair dryer, the motor and heater receive the necessary current. The heating element then emits heat. The electric motor spins, which causes the fan to spin. The fan generates airflow, which directs down to the heating resistance and then out of the barrel as hot air. Heating element. A hair dryer heating element is a metal coil that is put over a non-conductive substance. Wire 1 resistor are a type of resistor that is made up of two sections. The first is a cylinder core made of ceramic, fiberglass, or plastic, while the second is a high-strength metal wire. This element's fundamental functioning principle is to convert electrical energy into heat energy, which causes the air supply. This element's fundamental functioning principle is to convert electrical energy into heat energy, which causes the air supplied by the fan to become warmer as it passes. Next, fan of the hair dryer. The fan functions as a transformation device, transferring heat air from the hair dryer to the hair. The motor's mechanical energy passes through the fans that are attached to it. This device aids the rotation of the fans around the edges. The air from the fan passes over the heating element as a result of this circular movement, blowing the heat from the coil to the exterior through the wet hair. Next, we move to objective of this project. The hair dryer assembly project was one of the gadgets that could be made using the microprocessor 60SK. The goal of this project was to implement all of the microprocessor components needed to create an application. The 68K instruction set was used to construct a variant instruction in this project. In general, this project used microprocessor principles such as arithmetic instruction, byte manipulation, program control, stack, and subroutine to develop a coding syntax that was used to create the application. Next is scope. The main issue with this assembly project is that the adjusted heat is limited to only low, medium, and high temperature. This heat volume is controlled by microprocessor coding and may not be suited for some people's hair condition. To solve this problem, we may alter the code number in Easy60SK to control the fan speed and ensure that the heat is acceptable for all hair types.
So, Assalamualaikum warahmatullahi wabarakatuh. So, my name is Muhammad Firdaus bin Ishaq. I will continue to explain knowledge in our microprocessor project PBL. So, in this project, we have used in and out devices such as keyboard, button, mouse, and screen. And the software used is IDE 68K or Easy68K. And this is the definition of IDE 68K and the Easy68K. So we focus for the Easy68K, and the definition is Easy68K is a 68K structure assembly language IDE. Allow you to edit, assemble, and run 68 programs on the Windows PC or Wine. No additional hardware is required. Easy68K is an open source project distributed under the GNU Public Use License. So this is how the interfaces of the Easy68K. So we can see this is the coding. We write down. So this is the memory, and this is the hardware. So next, I will explain you method and methodology. So for method, we provide you pillar table, which is for the explanation of our project assignment, hairdryer. So from column 1, column 2, column 3, and column 4, we can see that for column 1, we write down knowledge. For column 2, the ideas, and column 3, learning issues, and the last one is the action plan. So for the row 1, microprocessor as a main controller, IDE Easy68K simulator, and the learning issues is how to use the software and the hardware, and the action plan is watch and learn the tutorial on how to use simulator on YouTube or Google. So for the row 2 is hairdryer, component, and its function. So the ideas is component connection, operation of devices, and the learning issues is how it works and what are the steps to use it, and the action plan is search the concept, design component, and the operation on Google. So for the row 3 is adjusted speed, and the ideas is speed control techniques, and the learning issues is what techniques can be used to control speed for 3 different kind of heat, how the program it in software. So the action plan is learn assembly language, design, and execute program. And the last row is adjusted heat, and the ideas is the heat control techniques, and the learning issues is what techniques can be used to control heat for 3 different modes, how the program it in software. And the action plans is also same for the row 3, which is learn assembly language, design, and execute the program. So next, we move to the flowchart. So this is the flowchart for our group assignment. So first box is we have start, and then we move to the input adjustable speed fan. And in adjustable speed fan, we have 3 conditions, which are first low, medium, and high. And then we move to the other box, which is input adjustable heat. And we also have 3 types of condition for adjustable heat. And the first one is low, second medium, and the last one is high. And then we move to the output adjustable speed fan and heat. So the last box is AND. So this is the flowchart and the operation, how the hairdryer is working in our assignment. So, and next we will show you the coding, operation, and simulation explained by Amar. So that's all. Thank you.
I will explain about the hairdryer program code. Firstly, there are steps start is the first instruction of the program. Then there also the declaration part. This declaration part is used to declare all the hardware that we use for this hairdryer program. For example, there are switch, LED, segment 1, segment 2 until segment 8. To declare all the hardware, we use command EQU. For example, switch EQU hexa E00012. After that, we need to assign the initial condition. Start from ORG hexa 1000. This shows that our program will run at memory 1000. Then we move .b immediate hexa 1 into D0. It will move immediate hexa 1 into D0. It goes for the same as for switch D1, D2, D3, D4 and D5. This shows that this is important because it will decide the sequence of the switch that will be used and that will be pushed in the simulation later. For the next part is the main loop. Main loop is important because it controls the whole program, so it can run smoothly. First of all, we move .b D0 into LED. Then we use cmp.b switch D1, and if D1 value is high, it will jump to subroutine startup subroutine. This goes for the same for the second switch, third switch, fourth switch and fifth switch. But the jump will be different. For second switch it will be hit 1, third switch will be hit 2, fourth switch will be hit 3, while fifth switch will be stopped. We also use command BRA main to make the program loop continuously. Then we go to the startup subroutine. This shown move.b for the segment 1 until segment 8. We use this command to show the data in the 7 segment display in a certain form. Then we also use the same command for BRA main. It will loop to the main condition, so the run will be the program will run continuously. Then there also the hit 1 subroutine. We use ROL.b immediate 1 into D0. This will rotate operand to the left into D0. Then we use move.b D0 into LED. The value will be jumped to branch to subroutine loop. And for the bottom part of the hit, it will be the same. It will display the specific form that we choose in a 7 segment display. This go for the same for the hit 2 and hit 3, but hit 2 and hit 3 it will jump to the branch to medium subroutine for hit 2, while hit 3 it will jump to branch to high subroutine. Then we for the next part is the stop subroutine. Stop subroutine, we use the blink command. For example, move.b immediate hexa FFD0 and move.b immediate hexa 00D0. This will make our LED will blink and it will jump to subroutine off. For the last part is the delay subroutine. Delay subroutine is important in data manipulation for heat and speed for our hair dryer. For example, off subroutine. Off subroutine, we use move.l immediate hexa 9000 into D7, and we use su sub I.w immediate 1 into D7 and BNE with 0. RTS will be the loop for the data manipulation. If the value for this data manipulation is lower, for example, if the data manipulation for off is below 9000, the speed and heat will be high. We also have low subroutine, medium subroutine, and high subroutine. These three subroutines show that in our program, the low is for the low heat and speed, while the medium is the medium heat and speed, while the high is the high heat and speed. Then we will end the coding by using END hexa 1000. Then we will start to run the program in the hardware. Make sure there are no warning or error. Then we can execute our program. This will be our program for the hairdryer program code. Then we check on the view and click hardware, then click interrupt 1, and when we push the first switch, it will show on, so the hairdryer will be on the startup program, so it will be on. Then we push the second button. The second button is for the low heat and the low speed. Then for the next button is the third button. The third button will change the heat and the speed into medium condition. And for the fourth button, it will be the highest change in terms of heat and speed. Then for the last button, it will off our hairdryer, so the heat and the speed will be start to run slowly until it off completely. This will be our program for the hairdryer, and this is the result for this hairdryer program code. Thank you.